Okay, so now we continue the engineering materials. So in the first period, I told you about how we use it, materials in the building design and also energy efficiency. So now we will detail examine their materials chemical structure. So especially their materials are the bonding between the atom and the electron. They determine the insulation properties or the semiconductivity properties. Because when there's an insulators are they got the electron and the nuclear got a very strong force. But for the conductor, very loose force. So the conductor the electrons are passing through from the one atom to the another atom. So they are force between the electron and the nuclei is loose. So that when you get that external energy, so electron can be flow. So now we will detailing examine about how they are the material structure and what can be what kind of the force is it in the metals. So normally the electrons we can see that the energy levels. There are two levels. One level is EV and another level is EC. EV means that this is the balance electron energy. The balance electrons are offering that kind of energy. So that time the electrons are not moving. So they are attached to the nucleus. When the electrons receive the external energy, so then they will be go to the conduction energy EC level. So that time the electron move from the one place to the another place. So this is the way the conduction can happen. Conduction can happen for the electric flow, current flow, and similarly heat flow. The heat particles are also moving like this. So this is for and change of the energy is the basis the factor that determine the conduction or the resistance. So this means that EV is equal to the balance, energy balance level. The EC, the energy conduction level energy. So when the electron receives the conduction level energy, then the electron wave them moving. So therefore that we can see the electron level depending on the kind of the materials. Kind of materials we can draw the energy level. Some of the materials this is the EV here, and some of the materials called the EC. Some materials are color this go this way, some go to this way, and some are the horizontally like this. So this is kind of the energy waves depending on the kind of materials EC and the EV gas can be brought like this. So this is the EC and EV gas. Depend on kind of materials. So in this case, this energy distribution level. So therefore, every energy distribution level can be plotted like this. So you can see that some energy needed a little energy to excite the electron to move through, and some are the energies a lot of energy requires to move through the electron. So this is for the energy distribution curve. So this level we call the Fermi level. So Fermi level is a level. This means this determines the space density. So this becomes how much electrons are density and the space density get determined as a Fermi level. So in this case, some of the electrons can easily move, some electrons cannot easily move. So depending on how much energy is exerted on this electron, so that energy level we call it a Fermi level. Also find out the Fermi level. In this case, the electron level is this is the E1 with the level energy state 1, E2 with the energy state 2. So this is energy state 1. E2 is the energy state 2. So the E1 and E2 are divided by 2, that will be the EN. So this is the Fermi level energy. Is equal to E1 plus E2 divided by 2. So this is the way that we can calculate the Fermi level. In the electron, we also got the neutron and the proton. So that the neutron got the electron energy, also proton got the energy. So this is PE is equal to the proton energy, and the NE will be the neutron energy. So this becomes the P-type and the N-type semiconductor material. So PE may be P-type material, semiconductor material.
So when they come in, don't have
energy. And the N-type semiconductor material energy. So that all that the semiconductor materials, they are combined in the N-type and the P-type semiconductors. So there will be the E will be the P-type semiconductor material energy, and E will be the N-type semiconductor material energy. So in this case, we can define which one is the insulator and which one is the conductor. So insulators are resistively more than 10 power 8 ohm centimeter. This is the insulator. And conductors are resistively less than the 10 power minus 3 ohm centimeter is we call the conductor. And semiconductor can be the germanium or the silicon. So this is the way that we can discriminate which one is insulator or which one is the conductor. Insulator, resistivity more than 10 power 8 ohm centimeter, especially the glass, mica, they are the insulator. In the mid-type, we can see the conductor, resistivity, so less than 10 power minus 3 ohm centimeter. So there will be the semiconductor can be the germanium or the silicon. So in this case, our silicon transistor is the solid state device. The passing of the current is determined by the binding force, which is between the positively charged atom and nuclei. So this means that all the atoms they are surrounding the nucleus, so they are also moving around the nucleus. So all the atoms are moving around the nucleus. That will be the nucleus here. Nucleus called as electron, a proton, and a neutron, and they are moving around the electron. So the electron is moving around the nucleus. So the force between the electron and the nucleus called the force, the big force. So these forces are the binding force. So this binding force is unlike this insulator and conductor. Insulator means that the binding force is very strong, and conductor is the binding force is very weak. But for this transistor, depending on the excitation, depending on the free excitation, the amount of the energy excited on the electron can be determine the electrical current flow. This means that all the electrons are semiconductors that you need to give the excitation current. So it's the P and C and E here. Base conductor emitter. So you have to get the between base and emitter. This means the excitation current. Excitation current means that the energy level need to be excited so that the electron will be jammed to the conduction level and will be moving through. Need to be excited so that the electron will be jammed to the conduction level and will be moving through. therefore the reason is we have to reduce the force between the binding force between the nucleus and electron by providing that the excitation current the electron can be moving. So this is the way that we can construct the semiconductor. So this is what ways a conductor or the semiconductor or insulator can be forming. The conductors, insulators are resistively more than the 10 power 8 ohm centimeter, and conductors are resistively less than the 10 power minus 3 ohm centimeter. The transistor is a solid state device. The passage of the electrical current is determined by the binding force which acts between the electron and the positively charged nucleus. This means that normally that the force is strong, so by providing the appropriate energy, the force can be reduced and the electron can be moving. So this is why we have to get the excitation. So between B and E, you connect the connection to the voltmeter and electrical supply, DC source supply, so that we can reduce the electron's energy level. Normally, this is the potential barrier here. This is the potential barrier. This is the electron. Electron cannot climb up the potential barrier at the normal condition. But when we giving the pre-excitation, this barrier can be reduced. So this barrier can be reduced. Reduction of barrier. Of potential barrier. By pre-excitation. So in this case, the electron normally cannot move around, but when the potential barrier is reduced, the electron can be moving. So in this case, there can be the conduction happen. So that kind of materials are the semiconductor materials. So semiconductor materials, by providing the excitation, we can reduce the potential barrier. So in this case, those materials are moving with the energy. When any particle is moving, they possess the energy, and they also got the mass. So that we use as equation. The equation that relates the charge of the electron and their velocity, the mass, and the radius distance. So this is the electron, and this is the nuclear. The distance with the radius. Radius of the orbit can be written in the equation. So this becomes the E squared divided by the 4 pi E0 squared, E0R squared, equal to the mv squared divided by R. In this case, E means the electron charge, and M is the mass of the electron, and the V is the velocity of electron. And R is a radial orbit. E0 will be the permittivity. And in this case, pi is 3.1416. So this equation is the equation to calculate how the electron charge and their moment and their mass and the velocity are rated. So this equation describes the charge of the electron, mass, velocity. So charge of the electron, mass, and the velocity are written by this equation. So another way be when the energy fall onto some of the material, the photon can be jumping out, especially the solar panel. Solar panels are when the light energy fall onto the solar panel, so that it can excite the electron, and the electron will be moving. So this means that photons are voltaic materials. So photovoltaic materials are also utilized in the energy efficiency and also the solar panel design. So in the previous lessons of past, I told you about the energy efficiency and the solar energy. When the solar energies are fall into the solar panel, it will excite the electron. So this electron excitation and the amount of the absorbed energy can be written as equation. So this equation is described by the energy in the quantum. So this is because the Bohr's theory. Bohr theory of hydrogen atom. So this means that this is a solar panel here. So this is for the heat energy coming. So in this case, electric current flow. So this electrical current flow and the heat energy. In this case, this for the sunlight. Sunlight is really the electromagnetic. So this sunlight contains the electromagnetic waveform, so that those electromagnetic waveforms are exciting the electron to the moving. So in this case, we write down the equation. This equation for the all energy emitted and absorbed in the form of the multiples or unit. This is we call it a quantum. All energy is emitted and absorb it. In the form of multiples or unit. It's called quantum. So in this case, we can write down the things like energy in each quantum. The E can be calculated, H multiply V. So in this case, E is the energy, H is become the Planck constant. So Planck constant, the unit will be the 6.62 into 10 power minus 34 joule second. And this V is the frequency of radiation. So this means that when the electrons sunlight is fall onto the solar panels, the solar panels will absorb the energy. So this energy is excited and this energy is force the electron to move through. So this is the point why the electron solar panels and the solar photovoltaic materials are constructed. So as today's reader, we are talking about the materials. So the first part is that I show you how the materials are utilized in the building construction, energy efficiency, and this part is the details construction, the principle of the materials. All the materials got the two energy states, so energy balance and the conduction level energy. So normally the energy balance level means that here is not transmitted or the no electric current flowing. This is the energy balance. When the low electron got the starting level of energy, they can be excited and they will be moving. So this equation is the energy balance diagram we can draw like this. So the low energy balance diagram, EC and EV diagrams are different from the one material to another material. So low energy distribution level can be drawn in this graph. This we call it the Fermi level. So normally there are two states of the energy. One will be balance, another will be conduction. So that the average of the energy at the two stages will be the Fermi level energy. So we can notify the here. So depending on the kind of the material, some material absorb energy and can easily move away. Some electrons cannot move. They got the binding force strong. So it can determine the insulator and the conductor. So insulators are resistively more than the 10 power 8 ohm centimeter. Conductors are resistively less than the 10 power minus 3 ohm centimeter. So normally the electron moving the nucleus, the electron got the negative electricity, nucleus got the positive. This binding force is strong. So when you get in the sun excitation, the binding force can be reduced and the electron can be moving. So that kind of materials we call the semiconductor. Semiconductor material means that they usually got a strong binding force at the stable state. That when you the energy level will be stronger and stronger. So that those stronger energies are force the electron to move through. So in this case, the change of the energy is related to the amount of the electrons to move through. So this equation can be written. So this equation will be the E1 minus E2. So energy different. This becomes as ionized energy. So this energy will be the E is equal to the, in this case here you see the two energy level here, EC and EV, EC minus EV. So this ionized energy means that energy is inside the solar particles to motion through. So this is the E equal to the EC minus EV. So that equation can be written. This equation is equal to H multiplied V. So the E equal to EC minus EV equal to the H multiplied V. So this becomes the photon, this is also called the photon radiation. So photon radiation, it means the absorbed electromagnetic energy.
So it's dangerous?
Absorbed electromagnetic energy. So that when the electric field fall onto the electron, the electrons are absorb the energy and the electron will be moving, especially the solar cell. Then we can the photons are radiation. So once the electrons are moving, that they possess the kinetic energy and the potential energy. So the moving electron possess the kinetic energy and potential energy. Once the electrons are moving, they possess the kinetic energy and potential energy. For example, the aeroplane the flying above the ground level. So in this case, that aeroplane is moving. So it's called the kinetic energy. In the meantime, they are above the ground level. So they are above the ground in the sky. So they also suffer the gravitational force. So this aeroplane has two forces. One is the kinetic energy, another one is the potential energy. Similarly, the electrons are moving around the nucleus. Once the electrons are far from the nucleus, they also possess the potential energy. Potential energy is a reference from the nucleus. They call them potential energy. In the middle, electrons are moving, so it also has a kinetic energy. So that those electrons are energy excitation, they force the electron to move through. The electron also possess the kinetic energy and potential energy. So this kinetic energy and potential energy in the electron can be calculated. So in this case, kinetic energy equation is Ke is equal to the E squared divided by, this is the equation is half into mv squared. This is equal to the electron release E squared divided by that 8 by E0 into R. So this is the kinetic energy of the electron. In the meantime, the P can also be calculated. P is the minus E squared divided by 4 by E0 R. And therefore the moving electron possesses the Ke plus Ne. So this is En, moving electron energy. Equal to Ke plus Pe. So in this case, Ke can be written E squared divided by 8 by E0 R minus Pe equal to E squared divided by 4 by E0 R. So this is the equation. So that will be the, by writing this one, that will be the minus E squared divided by 8 by E0 R. The principle of the chemicals are balance and the atomic are binding. Can we get balance? atomic binding. So chemical balance means that some of the chemical balance in the electron and the protons they are combined. In this case, we can neutralize the chemical. For example, so oxidation. Normally, the hydrogens are H2. H2 is a hydrogen, and O is the oxygen. So when you are combining the H2 and O, H got the positive and the O got the negative properties, so that they bind in, so that will be the one you have is the H2O. H2O becomes the water. So this will be the balancing the two positive charge parties there and the negative charge parties there, they bind it together, and then that will be it can be the H2O. So in this case, H2 got the positive property and oxygen got the negative property. So by combining, that way water has a neutralize. So this becomes the chemical balancing. Especially the acid and the base. Acid got the acid property and the base property. So H2SO4 is sulfuric acid, and base are the sodium peroxide. Those are base. So you combine the acid and base property. So what happens is that you can neutralize. This
H2 plus O2 equals H2O.
Yeah, H2O. This one you have to balance. You have to make this one. Yes. So we mixing the acid and the base. When you are mixing the acid and base, so that can be neutralized and the water coming out. The water no longer has the acid or the base property. This is we call the chemical balance. So the chemical balance can be happen. Normally we combine the positive and the negative charge making a combination. At the meantime we can produce it. It can happen the chemical balance. With the energy level. So energy level is a change from the one condition to the another condition. When the energy level is the cells the atoms are electrons are very closer to the nucleus, because there's a higher energy level. And they far from the nucleus, they will reach a lower energy level. So this becomes the electrons are energy level. Electron. So the energy level of inner shell is higher than outer shell. So the electrons are usually possess the energy. They are moving around the nucleus, so they call the energy level. So that the closer to the inner shell, so they will be the higher the energy level. So the definition of the transistor is a solid state device. The density of the current is determined by the binding force which acts between the electron and the positively charged at the nucleus. This means the binding force is determined by the outside influence. Normally the binding force is strong, so normally this transistor does not conduct the electricity. But when you give the free excitation current, so the binding force can be reduced. So that therefore the electron can be moving. So the density of the current is determined by binding force. So the density of current is determined by the binding force, so which acts between the electron and positively charged at the nucleus. So this is the definition of the transistor. Another question. So the next one will be the question for the Bohr theory. All energy emitted and absorbed in the form of the multiple unit called the quantum. So this means the energies are emission and the energy absorption can be measured in the unit of the quantum. So in this case, energy in each quantum can be calculated E equal to H multiplied V. V is the frequency of radiation, H becomes the Planck constant. So the Bohr theory is that the basic theory all energy radiation, absorption are measured by the Bohr theory. Similarly, the home electrical theories are home energy efficient building design. So we measure that the heat energy will flow into the building. Those heat energies are normally this is all the heat energy. Those physical terms can be analyzed by the Bohr theory. So E equal to H multiplied V. Frequency of radiation. So this means that more heat that fall onto the building, so it becomes the more higher frequency. Higher frequency happen. In this case, the more energy will be moving through. So this is the E is based on the H multiplied V. So this saying that we are explaining that in terms of the material science, previous part one is that we can really using the utilization, how we utilize, how we calculate the heat flow. Now we are more detailedly analyze what is the heat, how we analyze the heat, and also those are how it related to the quantum theory. So this is for the second part is the more detailed analysis according with the material science. So this means that ionized energy or the photon radiation is energy difference between n equal to 1 and n equal to the infinity. N equal to 1 is that within the atoms, there's electrons are moving at the parts n equal to 1. N equal to infinity means that those electrons are coming out and they go out from the starting atom, so they will be the infinity. Infinity means electron has already been moved out. So the energy difference between the moving electron and the inert electron exit in the initial state, there will be the ionized energy. Ionized energy E can be calculated E infinity minus E1. E infinity means that the electron possesses the energy while it is moving and coming out from the atoms. But E1 is the initial state of the electron energy. The difference is the ionized energy. Can be calculated me power 4 divided by 8h squared E0 squared. E0 means that originally this called the energy level body, and also E is the electron, and it's a mass, H is the Planck constant. So this equation is the photon radiation equation. So chemical stability means that when the positive charge and the negative charge are combined, the combination approaches the chemical stability. This means that positive ion is a hydrogen ion, negative ion is a oxygen ion. So that the positive and negative makes a combination. So that will be that water can happen. Water will be that stable. This means that especially the sulfuric acid and the acid property, and also the potassium hydroxide is a base. So we combine the sulfuric acid and potassium hydroxide. What happens is the H2SO4 plus potassium potassium KOH. So what we can measure is the K2SO4 plus H2O. So that will be the chemical combination. So in this case, that will be the acid properties. Here are the base properties. So both are the neutralized. So neutralized properties can happen. In this case, normally the positive charges and the negative charges are made combined. So the combination approach the chemical stability. So that chemical stability effect can also be explained by the quantum theory, and also the electromagnetic interaction or charge interaction can be explained. We are talking about the insulator and the conductor. And normally the insulator, why is the insulator? Very simple answer with the insulator is to prevent the flow of the electricity or prevent the flow of the heat. This is the insulator. Conductor, electricity can flow or the heat can flow. So this is a very simple answer. But this one is a more detailed we analyze how the electricity flow, why electricity can't flow. In this case, we have to detailedly analyze by the material aspect. Normally, all the material, they got the three kinds of bond: valence bond, forbidden gas, and the conduction band. Valence bond means that at this valence bond condition, this condition, all the electrons are not moving; they are stationary. Similarly, all the metal, that metal is no electricity, and you touch with it, this one to electricity. They are the stationary condition. They are balanced. So that between the valence bond and the conduction level, there will be the gap. The gap means that this is the conduction gap. For example, this is the stair. So you want to go to this way, you have to climb up this stair. Okay? So how different? Building K and the building L. Very different. Building L, you can go to the lift, you can press the switch, and then you can lift up. And within 1 minute you will building L, you have to climb up. This is the building A, you have to climb up. Some people with that some people are very tired to climb up the top floor level. So this is because what happens is building A is similar to the conductor. You switch on the lift and then you can reach the top floor. But building K is similar to the insulator. So to reach the top floor level, you have to climb up. So this is the way the energy gap there is. This is the minimum. So this is the forbidden gap prevent the electron to flow. So this is the forbidden gap. So this forbidden gap energy level is very enormous for the insulator. Insulator very difficult to the electron to pass through the balance form. So forbidden gap is a very strong. This is the insulator. At the normal condition, at the room temperature, conduction band is empty. Conduction band there is no moving electron in the conduction band, and forbidden gas is greater than the one electron volt. So this is the enormous electrons energy level. There is no electron in the material which can gain enough energy to cross the forbidden gap. So the electron cannot pass through the forbidden gap. Conductor, outer electrons are loosely bound. This conductor is the forbidden gap is very small. Outer electron loosely bound, so that when they receive the pure energy, so electron can easily move. This is for the conductor. So conductors are different from the insulator. Conductor electrons are very freely move. Insulator, the forbidden gas is very too much. So sometimes a breakdown of the insulation means, although this forbidden gas is too much, some things are external very strong forces can destroy the band level. The times are the breakdown of the insulation happen. Normally A is a very insulator. When the electric energy is too big, about the 30 kilovolt, 40 kilovolt, then the electrical current can pass through this for A. Similarly, your paper is normally the insulator. But you touch this paper to 1 kilovolt electricity, this paper can be burned out because of the electrical current too much, so all the forbidden band totally destroyed. This is the kind of the insulation breakdown. So that we can explain the insulator and the conductor in terms of the material science aspect, as well as we can explain why the insulation breakdown, what the reason, energy diagram, we can explain like this. Okay, that's all for